Hello students, welcome back to part 2 of our topic relations and functions. In the last class, we learned about standard functions and their graphs. Today, we'll understand the most important part, types of relations such as one-one, onto, and bijective functions. We'll also learn how to check them and see some examples. A function is said to be one-one or injective if every element of the domain maps to a unique element in the codomain. That means no two different inputs have the same output. Example, if f of x is equal to 2x, then f of 1 equals 2 and f of 2 equals 4. All outputs are different, so it is one-one.
Sir, how do we test it?
We can test by assuming f of x1 is equal to f of x2. If this gives x1 equals x2, then the function is one-one. A many-one function means that two or more elements of the domain have the same image in the codomain. Example, f of x equals x squared. Because f of 2 equals 4 and f of minus 2 also equals 4. Hence, it is a many-one function. A function is called onto or surjective if every element in the codomain has at least one preimage in the domain. That means nothing in the codomain is left unmapped. Example, f of x equals 2x, where both domain and codomain are real numbers. For every real value of y, we can find an x equal to y divided by 2. Hence, it's onto. If there are some elements in the codomain that do not have any preimage in the domain, the function is called into. Example, f of x equals x squared, domain real numbers, codomain real numbers. Here, negative values like -1 or -4 have no preimage because the square of any real number is never negative. Hence, it is an into function. When a function is both one-one and onto, it is called bijective. That means every input maps to a unique output and every output has a corresponding input. Example, f of x equals x plus 1 for all real numbers. It is both one-one and onto, so we call it bijective. Let's visualize these using simple arrow diagrams. In a one-one function, each arrow from set A points to a different element in set B. In a many-one function, two or more arrows from a point to the same element in B. In an onto function, every element in B receives at least one arrow. And in an into function, some elements in B are left without arrows. These diagrams help us see how domain and codomain are connected. A quick way to check if a graph represents a function is the vertical line test. If a vertical line drawn anywhere on the graph cuts the curve at more than one point, then it is not a function. If it cuts at only one point everywhere, then it is a function. Example, the graph of y equals x squared passes the test, so it's a function. But the graph of a circle x squared plus y squared equals 4 fails the test because one vertical line cuts it at 2 points. Let's recall some useful formulas. Number of functions from set A to set B equals n raised to the power m, where m is the number of elements in A and n in B. Number of one-one functions equals npm, that is, n factorial divided by n minus m factorial, if n is greater than or equal to m. Number of onto functions equals n factorial multiplied by the Stirling number of second kind s of m, n. Greatest integer of x means the largest integer less than or equal to x. Fractional part of x equals x minus greatest integer of x. Signum of x equals 1 when x is positive, 0 when x is 0, and -1 when x is negative. Question: check whether the relation are equal to the set of pairs 1, 2, 2, 3, 3, 4 from set A equal to 1, 2, 3 to set B equal to 2, 3, 4 is a function. Answer: yes, because each element in set A has one and only one image in set B. Question: is f of x equal to x squared a one-one function? Answer: no, because f of 2 equals 4 and f of minus 2 equals 4. So different inputs have the same output, it is many one. Question: find the range of f of x equal to modulus of x for x between minus 3 and plus 3. Solution: since modulus of x is always positive, the range is 0 to 3. Question: find domain and range of f of x equal to square root of x minus 2. Solution: inside the square root, x minus 2 must be non-negative. So x is greater than or equal to 2. Hence, the domain is x greater than or equal to 2 and the range is 0 to infinity. A real-life example of a 1-1 function is a roll number system in a classroom. Each student has one unique roll number, no duplicates. That's how injective functions work. Let's summarize what we learned today. 1-1 or injective function, unique mapping. Many 1, 2 or more elements share the same image. On to our surjective, all elements in codomain are covered. In 2, some codomain elements are left unmapped. Bijective, both 1-1 and onto. We also learn the vertical-line test, important formulas, and solve examples. Keep practicing these concepts, and in the next session we'll begin inverse functions and composition of functions. Till then, take care and Jai Hind.